Can you hear me? Welcome to RPI, even if it's virtual, but welcome to RPI. And today I'll try in 30 minutes or so to walk you through the degree at RPI, the biomedical engineering degree, and what's involved and why you might want to do that. And then I'll stay after this for questions, as many questions as you have. So my name is Hisham Mohammed. I am a lecturer at Biomedical Engineering Department, and let's start. So we'll talk about what biomedical engineering is. Why would you want to become one? I think now is everyone wants to become a biomedical engineer. At least that's my feeling. And if you decide to do so, how it will look like going through the RPI, through the department at RPI. So I left here some web page and Twitter and LinkedIn and connection. But I think the best way to get the information is to go on the main bme.rpi.edu, the main department webpage, and look for a person that you can ask questions. You can email them, and if it's not their field, they can point you to who will answer your question, and you can find also department head there and take it from there. So we are academic. We like to start with definitions. So what do biomedical engineers do? We solve problems that are related to medical and health. We come up with devices that will make procedures faster, safer, or even possible to start with. And everything that you find in a clinic when you walk in, everything that you see in a hospital or you don't see behind the curtain, or anything that's in the diagnostic lab that you go to that handles your blood or handle any of your samples, are all biomedical examples. So for that, we have to be able to understand biology. We have to understand how the body works, understand how the medicine or the healthcare system is delivered. And we have to also have our core engineering to be able to design solutions for that. And working within the regulation framework that the FDA provides or the government provides to make sure that our solutions are safe and do not cause any problems. So biomedical engineers, after they graduate, they can go work for industry, and there are multiple functions that they can do. They can be a research and development engineer. They can be working on other functions. They can go to graduate school to have a master's or a PhD. After that, they can go back to industry to work there to do research and development. They can go back to academia to teach and do research, or they can join a government, either a research lab, or they can join the regulation like the FDA and other bodies that regulate the biomedical field. Many of the great research is done not just in academia, not just at Harvard and MIT, but are also done in government lab on the federal level and on the state level. So there are a lot of opportunities to work also for the government, and they're a very good one. Some of our students choose to go to medical school. So we have a pre-med template where they can follow. I will talk about that. And some can work in the hospitals. They can work with the people there to design new imaging sequences, or look at the images in a different way, or do something different, develop something different, like people that are working now for the ventilators. There are a lot of jobs also to work in hospitals. So there is a wide variety of jobs that you can do after you are done with your undergraduate degree. So some examples, you have imaging. You can work on imaging technique, monitoring all the equipment that's used for monitoring of the ICU, or after this, implantable device, pacemaker, surgical instruments that goes in or used during the surgery, prosthetics, diagnostics. All of these falls under the device and imaging umbrella. It can work for manufacturing too, tissue engineering, doing a mesh, for example, for hernia mesh, doing for tissues replacement for burn victims. You can do also, you can work for the government, as I said, for regulation, for the FDA. And also you can work for a institute that does data science, or you can work in data science area, where we are trying to learn from data, from previous experience, to try to predict what the future is without a crystal ball, but using the data and experience from before. So you can see these days, of course, data plays a very important role. Who gets infected, when they're transmitting the disease, how long does it show on them before the symptoms show up after they are infected. All these are data that gets collected, samples from different patients' DNA, and these can be used in the future to predict how the disease progressed and how we can contain it and have a better way of doing this in the future. So all of these they resonate with the area of concentration that we have in our degree: imaging, devices, biomaterials, data, and so on. So why would you become a biomedical engineer? We work, as I said, on new procedures, try to improve diagnostics, make it safer, make people stay less at the hospital, make people come back less frequently, have issues with their surgery or anything else less. You try to make health service more available. It used to be a hard sale before that. But now everybody understands how availability is important, how to have availability of tests, how things can be done quickly, how we can get the test back in a day or in hours instead of a day or two. So we try to make healthcare system more efficient, less expensive. It takes a big bite out of our GDP. So if you can make things more efficient, people come less back to the hospital, people need less treatment, or they need less stay at the hospitals. That will help save on the grand scheme of things. So it's a good job. You can go out and see the numbers for the salaries. Biomedical engineering is a good job. It's a growing field. It grows 6 or 7% every year, predicted for the next 10 years or so. The one thing I will add here, you can find all kinds of statistics online that will tell you how rewarding that is. But the one thing that I will tell you, it's a very satisfying job. When you work for a company, R&D, you're doing new treatment, or you are doing new discovery, or you are going and applying your device on a pig or an animal and see what the results are. It's very rewarding and satisfying job, not just for the pay and for the growth, but for sure there is no shortage of jobs, and they're good paying jobs. So let me walk you through a little bit what a degree will look like at RPI. And this picture, if you have visited campus, this is Dr. Johnson. This is statue in front of the building, GEC, the Johnson Engineering Center, and it's named after him. He was one of the founders of a company that became after this Texas Instrument. He's an RPI alum, and you'll see his statue as you are going into the building. And the one thing that I like that in the summer, as you can see, people have put sunglasses on him. In the fall, you'll see that sometimes students will dress him with a scarf. Halloween, they'll dress him for Halloween. So he's kind of like a living thing with us with every semester. And I take some pictures for him when the students do that. So I can share this picture with you later. But he is a part of our culture and part of our place. So let's talk about degree a little bit more specific, what's at RPI. So as I said, we have 5 concentration areas: biomaterials, biomechanics, bioimaging, biomedical data science, and medical devices. And biomedical data science is a new area that we have added this year. We used to have a bioimaging and bioinstrumentation that we divided into because we saw the need of having more medical device areas. So the students can pick any of these, and it will be on their degree as their graduating that they have what area of concentration they have. And of course, there is coursework that everybody takes. And then when they pick their concentration, there are another addition to that. So this is how our degree template looks like. It's dry. I'll not talk about it much. It tells you every semester what kind of classes you are taking. It tells you what the sequence is. It's very important to follow it as closely as possible, because first, some classes will be a prerequisite for another class, so you have to take them in order. The semesters are very well designed for a balance of load and preparing you for the next phase. And the schedule also is designed so you don't have conflict in times and you can take all these classes together. If for any reason you divert away from this template, you might have, if you keep a class that you're supposed to take the first year or second year to the last semester, for example, you might have hard time scheduling because it was not meant to not overcome with the classes on the last year. So I would encourage you all to follow the template as closely as possible. And if you diverge from it, try to keep it to minimum. But the template as is like this, it does not show you. And your advisor, of course, your academic advisor can help you navigate this and work around it. Of course, you might have some transfer credit, you might have taken credit somewhere else. So there are always kind of other scenarios where you don't follow this exactly, but try to follow it as close as possible to maintain the load too. A better way of looking at it, I like to look at it as that way. So instead of going top to bottom semester by semester, I will go bottom to top. And in this one, I would like to, so you can see that you start with some basic classes, engineering, math, biology, physics, and so on. So you can have the basic, the first year is mainly the foundation of this. And then you can see starting from the second year, you start seeing a lot of yellow, a lot of biomedical engineering classes. And the one that you start with are meant to give you the breadth first. So you have one for biomechanics, one for bioimaging and bioinstrumentation, one for biomaterials, and one for data science. That will prepare you for this. So these four will cover the 5 areas. And then you have more on the modeling of biomedical systems. And you have also more engineering where it's preparing you with a professional development component. So you have the breadth of your knowledge after the second year. You are kind of understand where we are going with this education. And before you go further, we have the summer arch where you can take classes in the summer and be away for a semester or two during the year. So by doing that, you can have a co-op or internship where you go out after you have done 2 years in school, and now you are ready to go and explore what do you want to do. Now I understand what biomedical engineering is. I understand what the different parts of biomedical engineering is, and I would like to explore, go work for a company or work for a startup or work for a lab and see how things are, and that will help me make my mind when I go forward with this. Then they come back from the co-op or the internship 1 semester or 2 semesters away, and now they're ready to for the next year and a half to finish. Now they come back to advanced physiology. For example, this is one of the star classes that we have, where they can do dissection on pigs and they can do small procedures. So they have hands-on with Albany Med, which is the biggest hospital in this area, Albany Medical Center. Then they do the lab where they have hands-on experience on how to do mechanical testing, how to do tissue, how to do other parts imaging, and so on. And then they have their elective. You can see that they have 4 or 5 electives, and these are free elective that they can increase the depth of their knowledge in any area. And then they have the biomedical elective, which is the depth in whatever area they pick, biomaterials or biomechanics or so on. So you can see after they come back, they have the knowledge, enough knowledge to tell them to start shaping their own education and where they go. So they get the breadth from the first 2 years or so and the solid foundation, solid technical foundation. And then in the last 2 years, they shape it where they have the depth in what they want to, and maybe some breadth they want to add to. So they have a say in their degree, and degree is very well designed to bring them when they're out of this, they're good to go and join grad school or any place. They'll be very competitive when they're out of RPI. So you can have a minor. Many people will have a major in biomedical and a minor in another classical engineering like electrical or mechanical. They're useful if you want to do that, if you take enough courses. There is a co-terminal degree also where you can stay a 5th year after you finish your bachelor and get a Master of Engineering. Many of our students choose that, so they have more depth in the area that they want. And we have co-terminal as engineering, and RPI also offer co-terminal as a mix between engineering and business. You can talk to the business school, they have a good program for that. And there are co-ops that help you get co-ops so you can get the experience after the second year where you can have a better choice of how to pursue your degree after this. There are study abroad programs where you can go to France and go to other places, work in a research lab or take classes somewhere else. It's made to an engineer is it's a person that you need to diversify their skills and the things that they know. So it's not just the classes that they take, but how other culture deal with problems, how hospitals are running other places, what are the regulations from one country to the other. the US and Europe and Japan, for example. So it's meant to make them well-rounded. So when they're in industry or they are tackling a problem, they know what the issues that involve in this. There are undergraduate research programs at RPI. They can join they join and do research with any of the faculty that does research at RPI. And we are proud to say that almost 50% of our students have a undergraduate research experience. And this is very useful if they're going to go, for example, for grad school after this. And it's useful in general because you go into the lab and you're working with a problem and see what the issues are. And there is a pre-med and physician engineer program that I will talk about. Pre-med is to prepare you for going to applying for medical school. And then the physician engineer program is a little bit limited in number, but allow you to be 4 years at RPI and get a bachelor, and then 4 years at Albany Medical Center, and get an MD degree. So the pre-med program is meant that you take all the requirements for a medical school. It's the one thing I'll say, it's challenging. You have to keep a GPA. Most of your free elective that I talked about in the last slides are not free anymore. You have to take they're consumed by some of the required pre-medical courses. The same thing for the HOTS, for the human and the human courses. Human and social science courses are also taken to meet the requirement for pre-med. But there is a template for it, and we have also 2 dedicated advisors that will help you navigate this template and help you when it comes to apply for medical school. Also, it requires a little bit more credit hours than the usual. It's you have to have some experience on some additional program that you have to join with the Albany Med or join in a hospital, and then you have to take the MCAT after the 3rd year to be able to join a medical school after the 4th year. So it's a successful program. It's many of our students follow it. It's very good. The only thing, as I said, you lose some of the freedom for the elective, and you have to keep your GPA. And we have a pre-med also in our book that will show you what classes to take in what semester. And I don't think you remember from the previous template, but from the previous template, we had a lot of things that says elective here, or you can take this, or free elective, or free BME elective. You can see on this template there is very limited free elective or free courses. Most of your courses are designed for you, so you can meet the requirement for the biomedical engineering bachelor and for a pre-med to be able to apply to a medical school. The physician engineer program is, again, it's a program. This one is done joint with Albany Medical College. The one thing here, that's your MCAT is waived if you go through this program and you keep a GPA of 3.5. Then you stay within the physician engineer program. And again, you follow the pre-med template, and you have, after 4 years at RPI, you receive the bachelor degree from RPI. And then after the 8th year, you receive a MD from the Albany Med. Students apply to it. There is data. If you choose to do that, I will ask you to talk to the 2 advisors for the medical school, and they will walk you through this. Some details, it's too much to talk about it here. In short, we try to keep our classes to be limited in numbers. So our elective courses are usually 20, 25 students, up to 30. Our core courses, they are in the 40, 30s, upper 30s, and 40 range. We have all professors have weekly office hours. We are all clustered in 2 locations. That's easy to access and easy to talk to professors. So it's always a good relationship between the professors and the students. And the one with good memory, I don't have a very good memory, but the one with good memory remember every name of the entire class. I'm still struggling with that part. But it's always meant for the students to be able to have their question answer feedback and get the best out of the materials. We are preparing the students to be engineers. We are preparing them to be designers for the future solutions. So we try to enable them with all the capabilities that it might need. So we have a lot of fabrication resources spread around campus. We have a manufacturing innovation learning lab, the mills. We have the MDL. It's another facility, and all of these are multiple locations. In the GEC, we have other location, and then we have a profab that's designed that's dedicated to the biomedical engineers. So when they do their design courses, their capstone, they are enabled. And also we have license for all the software that they might need, MATLAB, finite element, stuff like this. So they can do all their classwork, and they can also design. We have also a micro and nano fabrication clean room for making integrated circuits, MEMS, micro electromechanical devices, and small devices like sensors. One of the oldest in the nation, and it's very well maintained, and the students have a very good experience doing this. I just realized one of the things that I missed to point out when I was talking about degree, that there are one of the things that let me go back to it. I apologize for that. I will go back to the slides because I missed a couple of points here. So when I was talking about this, so when they come back, we talked about their elective and their design courses. But two things I should have pointed to. First, we have an introduction to engineering design. This is their first design course that they take, Engineering 2050. And they build something, and they'll give you an example at the end. Then they take their capstone at the end, which is a sequence of two courses, the last two, BMED 4260 and 4600. That's their capstone when they do a senior project for their design. These projects are all coming from industry, from clinician, and from like a Center for Disability in Albany. So are all coming from real problems, and they prepare the students to work on a real world problem and to interact with experts in that field. And the other thing that we take pride in at RPI, that we have two design opportunities, not only a capstone, but a capstone in Engineering 2050, which is IED, short for Introduction to Engineering Design. That's very important to prepare the students. As I said, at the end of the day, our students are designers. They get out and they design new solutions, and having two design courses is something that we are proud of. Most of our schools will have only one, and might be only one semester. Ours is 2 semesters plus this semester, so they have 3 semester long design experience before they go out. So let me jump back to where I was. I just realized that when I was talking about the capabilities, and these are some of the picture of the facilities existing around the campus. Includes the BME lab. It includes all the fabrication facility that will enable you to work on your solution. So I'll start wrapping here and start answering your question. Some of the examples coming from the IED, the Introduction to Engineering Design. So the students in this class, they pick their own project. They build a prototype. So this was a control for a skateboard, make it motorized and control it. So this was impressive. They built everything in metal. They went to the shop and they machined everything. So this was the final material. They went through several design iterations to be able to improve on this. They had CAD models, they had some simulation, and they also had some testing results where they tested this at night. If you have been on campus, this is a walkway from the 15th Street Bridge to GEC. And at night, they tested their system several times, recorded. And that's what engineering is about. You have a unmet need, you have a problem that does not have a current solution. You go and you design a solution, you engineer a solution, you test it, you make sure that this is what's supposed to be, and then when it's safe, you can roll it out. And they go through this design sequence in the IED. Another thing that we are also proud of, we have something called the Summer Clinical Immersion Program. This is a summer program that runs for 8 weeks with Albany Medical Center. I oversee this program for the last 2 years. So we have it depends on the year, but we have a handful of students, 6 or 8, that they go and they spend 6 weeks shadowing doctors at Albany Med. This is an experience that's unmatched anywhere. So biomedical engineers get to see how devices are used and to understand about the medical part of it, the medical aspect of it. So how things are used, how things are in the clean room, how patient care is, and all the issues related to this. They spend a week at the beginning getting their training on how to interact with patients, how to protect their privacy, and how to follow the protocols from the hospital, the safety protocols from the hospital. For 6 weeks, they shadow every 2 or 3 days. They're in different clinic, different in the operation room, attending whatever procedures are available for that day. They're separated in groups of 2, so we don't have a big group in one OR at the time. And then at the end of the day, they meet with a doctor at Albany Med. They meet with them at the end of the day, and they meet with them once weekly to talk about the procedures and talk about what they have seen and they have learned. They write their ideas in a notebook so they can make improvement on what they see, or if they see anything that can require improvement, they write this. And the last week, we put all these ideas, we research some of them, and we pick the winning ideas to go forward and use them in the Capstone project or follow up on them. A very good experience unmatched anywhere else, where the students pre-med or the engineering, the bachelor one, get an idea. Some of the pre-med one, after they did this, they said, I'm not sure I want to be a medical doctor. I'm not sure this is what I want to be doing every day. And maybe I will focus on being an engineer, and vice versa. Some engineers said, I think I would like to cross and go to the other side where I will be a doctor versus an engineer. Very valuable program. I don't think there is anything similar around the nation, and the clinical immersion program that are around that exist are very expensive for the students. So it's a very good experience for them to get this. Last thing that we are proud of is our capstone at RPI is a 2-semester capstone. In addition to the IED, students learn about engineering process, medical industry. They learn also about the regulation. They learn about intellectual property, patent, some of the laws that are relevant to what we do. They have all the projects sponsored by clinical and by industrial collaborators, medical companies, so they interact with experts in the field. They get to work on a real problem and make a solution that somebody will use or will follow up on. They have their own fabrication space. They develop a complete solution at the end. Along the way, they present their designs at different occasions, and they have to maintain documentation as if they're going to submit to the FDA. So it's a very good experience for them. They go through the entire process once. They know what's expected from them, and they know what a designer means. Even that a designer needs to know a little bit about IP law or patent law, needs to know a little bit about the FDA regulation. They know to know about reimbursement, how hospitals get reimbursed for their procedures, so they can be a better designer at the end of the day. They know when they're working in this environment, they understand what all the parameters that exist there, and make sure that the design is the best solution that can come out with this. So that's something that we're very proud of, and I will show you a couple of examples from our capstone. So we work closely with Albany Center for Disability. This is a center that deals with all the disabled kids in the area. They have all kids from all shapes and all spectrum of disability. And one of the problems that they have is their dentists on site have a problem because every kid has a different wheelchair. None of them is standard, different sizes. Some of them have different mobility problems, different cognitive handicaps. And so you can see the dentist has to sit on their knees, has to play acrobat to be able to provide regular dental treatment for these kids. So they ask us to have a dental chair that can accommodate any wheelchair and can still do all the function up, down, tilt that the dentist can do without them putting strains on their back and stuff like this. And we designed a solution for them, and they were very happy with it. The other one, it was a cane that will help a vision impaired person to not just to tap on the ground and see what the obstacles on the ground level, but to help the patient almost see what's around them. We send a series of sensors that can tell them if the obstacle is high, like the one on the truck here. It was meant that in the future it can read signs and tell them what's surrounding them, and tell them there is a sidewalk, there is a store, there is X, there is Y. So as they're walking, they're getting information from their cane with a earpiece, and that will help them to be safer and to get more function out of it. There's another project for a surgical device. You can see we took a surgical device that you see in the bottom. The black part is the original part. The white on the right is we took the gut out of this surgical piece to do our own. This is a surgical piece meant for doing suture when you are doing orthopedic surgery. and you cannot see on the other side. If you drill a hole in the bone and you'd like to do work on the other side, you cannot do that. So this tool helps you doing that. And it had some limitation, and we took the original tool and we were able to modify it and make it easier for the surgeon to work with it, and requires only one hand instead of having two hands busy with one device and having some other surgeon help with the rest of the procedure. Another example of looking at imaging and automatically being able to assess what the damage is. In this case, is a broken bone, and the broken bone, there are to heal this, there people are put in this device that will help them heal and bridge the bone to grow back to its normal length. And these devices requires adjustment daily for sizes and angle to make sure that the bone heals correctly. And this is usually, it's a plan that's made by a doctor, and it's the putting this device is a decision made by a doctor based on medical imaging. And the problem that came to us was younger doctor and experienced doctor sometimes come to a different conclusion, and sometimes the output of this is dependent on the doctor experience. So instead of depending on doctor experience, we made this automated. So then there is no, we took all the learning from experienced doctor and put this to make sure that the analysis of the image is automated, the generation of the treatment is automated, and get the best output out of this treatment. In conclusion, we have a flexibility. We have multiple track within the BME, preparing people for the future. We have, as I said, 50% of our undergraduate do research, get hands-on experience doing research. That's in addition to the hands-on experience that they get during their regular labs, BME lab, biology lab, the advanced physiology when they treat animals and pigs, and their work as IED and Capstone. We have dedicated pre-med advisors. Our classes are much smaller. If you are a physician engineer, you don't need the MCAT. You waive this and you can get to medical school easier. We have a very good working relationship with Albany Medical Center, which is about 30 minutes drive from where we are. And we have also a relationship with Mount Sinai. Albany Medical Center is the one that teaches the advanced physiology. So the students go there and get the class and get the hands-on experience. They have tons of resources and expertise to help the students become better designers, prepared better for tackling the workforce. And we have 3 design semesters to make sure that the students, when they hit the ground running, and they appreciate and they understand how things work professionally, but they also have an appreciation for continuing learning, because their education will not stop with their bachelor degree for sure. We are in a field that's fast moving, technology is moving, and they have to learn by the time that they're leaving school, that they'll be learning most probably for the rest of their life. So with that, I will conclude my talk. I kept it good, around half an hour, that's good. So there are more information that you can get on Twitter, LinkedIn, or just as I said, you can go to the webpage of the department and find somebody to talk to. You'll find me there, you'll find department head there and other people to talk to, plus the admission office, of course, they're your first go-to. They will tell you what the best way to get your question answers. There is also, if we are on campus today, you would have, after this, you would have walked across campus to go and have a BME lab tour, where you tour the biomedical engineering lab. Unfortunately, because of the social distancing, we cannot do that, but I put a link for the YouTube video where you can see 5 minutes tour of the lab. If you cannot capture this, just when you go on YouTube, just search for BME, RPI BME lab, or RPI BME, and you will, after a couple of clicks, you should be able to find it and go through the lab tour, tell you what we do in the lab. And with that, I think I will thank you. Thank you for being